Hi everyone, this is Blair Layton. I'm the Business Development Manager for Database Services across Asia Pacific at AWS. Welcome to the ANZ webinar, and today's topic is on migrating business critical applications to AWS with minimal downtime. The first things that I want to talk about are really about what customers are looking for when they're wanting to migrate to AWS and some of the problems that they're having. The first thing that often comes up is that, especially for business critical applications, they can't afford long periods of application downtime. And when they look at how they can mitigate that, the tools that enable it are pretty much expensive and sometimes quite complex to use. And that, when they look at it, then they say, okay, well, this is a bit too complex and a bit expensive to migrate. And then they say, okay, well, I don't think we can move some of these applications to the cloud. We're going to have to keep them on premise. Also, even if they do move some of the applications to the cloud, they would still need a copy of the data on premise, so keeping things in sync becomes a problem. And sometimes they decide that if they're going to move to the cloud, there might be an opportunity of moving away from commercial engines such as Oracle and SQL Server to an open source database as part of the migration. Another one is that when you're looking at the size of particular databases, especially if you're looking at doing data warehousing, then sending large volumes of data to AWS requires an expensive international network link for some of our customers who are sending data from different subsidiaries and different countries. Luckily in Australia, you do have reasonable networks to get into the Sydney data centers. The other one is they just don't have the skills inside their organization. So when you combine all of this, it does mean that even though some customers see the benefits of moving to the cloud and specifically the AWS platform, that they do have some concerns and pretty much on the fence or just decide that they can't do that. So if you were to look at this from a traditional approach, what would you actually do to move an application system to the cloud? Well, the first thing, obviously, you need to create your AWS account. And the next thing is to set up your virtual private cloud and make sure that you get all the networking set up in compliance with your on-premise standards. And then connect to AWS with a VPN or direct connect to make sure the connection's secure. And once all of that's set up, then you need to start planning the actual migration of your database and application. So you've got to shut down and back up your database, transmit that backup to our simple storage service, S3, configure an EC2 instance with the database software, restore that backup, and then configure all the EC2 instances for the application, and then switch the users to use AWS. Now this is high level, obviously there's some more steps in there. But if you look at 4 to 9 alone, that could take a week or more, depending on how much data you actually have to transfer and what your familiarity is with AWS and so forth. And most customers, when you say this is a business critical application, simply can't take that form of downtime. So now there is a better way. And what we've introduced is a new service, and this was introduced into the Sydney region earlier this year, and it's called the AWS Database Migration Service. The idea is that you can actually start your first migration in 10 minutes or less, and you can keep your applications running during the migration. We also support the capability to replicate data from on-premise to Amazon, either EC2 or RDS, and now Redshift as well. You can also replicate data from AWS back to on-premise, and you can also do data replication inside the AWS environment. Not only does it support homogeneous, it also supports heterogeneous migration of data as well. So the way that it actually works is that we set up, you can see here on the screen, your application users connecting to your existing application on-prem, and then through the internet, a VPN connection to AWS. And then we've got the database being set up on the AWS side, and once you start a replication instance inside AWS, then you connect up and say this is the source and this is the target. After that, you can select the tables, the schemas, or the databases that you would like the database migration service to migrate. And once that happens, then we start populating the data across, and then allow you, once it's complete, to switch that application from pointing to your existing on-premise to the AWS server. And once that happens, we're talking, minutes of downtime, basically refreshing your connections, making sure that your customers are able to restart their applications and the DNS change is propagated through. It's basically as simple as that. So a new capability that was just introduced recently was a multi-AZ option for high availability. So the whole process is basically the same, but this time, instead of having one instance, we're now going to be running 2 instances. So those of you who might be familiar with AWS, this is very similar to what we do in our managed database service, RDS, where we have 2 different instances running in different availability zones, so that if one has a problem, then the other one will be able to continue where that left off. Now, the idea for this is more for continuous propagation of data, where we're constantly taking data from on-premise and bringing it in to AWS. So same procedure, filling that across, and then moving everything into AWS. Looking at how we do this, we do support change data capture and apply. So if you can look on the source system, again on the left, you've got transactions coming in, updates happening, and transactions being recorded on the source. The replication instance receives those changes and then applies those to the target. Now, the way it works first is that we take essentially a select star, if you like, in the basic use case, on the table, and then we record the transactions that occur since that select star on the original table. And once the bulk apply has been loaded into the target, then the backed up transactions are applied on top of that, and once the backed up transactions are complete, then we continuously apply other transactions that come through. So this is what allows you to actually keep running your applications on-prem while you're doing the whole migration task. Looking at DMS, this is what it looks like from a console perspective. You've got some very basic interface here showing you about creating tasks to do migrations, and then some progress information about how that's actually going. There are some information in terms of errors and logs that you can get access to here as well. But you don't have to just use the console. You can use the API as well. So that means that you can programmatically build migrations or perhaps do tasks on a regular basis. Now, these tasks, you can use as many or as few as you want, even against the same database instance. So you could have different tasks doing different migration jobs. You can choose also the power, the speed, and the cost of your migration by using a T2 micro for testing, say, all the way up to a C4 4X large to do a major job with a lot of transaction processing. You can also choose the tables that you want, and you can, as I mentioned, do a whole lot of different scenarios from on-prem to RDS or EC2, EC2 to EC2, RDS to RDS, and RDS and EC2 to on-prem. Now, I forgot to mention at the start, if you do have questions, please do ask them in the question box, and we do have 2 solution architects who are on board to help, Sebastian and Kresh, so they'll be able to take questions and answer them as we go through. Looking at how the load actually works, it is done table by table. So you specify what tables you would like to migrate, and you can set up the parallelism as well. So the default is 8, and what will happen then is that it will initiate select stars on those 8 tables and start bringing all of that data through the replication instance and applying it to the target. If you believe that that's going to have too much of a big impact on production, you could reduce that, replication or parallel capability, say down to 2 tables or even 1 if you like. If you have a larger capability, you could increase that as well, so that's configurable. But it is a table-by-table process. You can actually take a source and split that up into multiple targets. So this is where perhaps you might have a large operational system on-premise and you would like to separate that into separate targets, perhaps for different reporting purposes, into the cloud. And again, you set this up from the replication instance and define where you want certain tables and data sets to go as a target. And you can set these up as different tasks as well, so you can control each of the tasks individually. We can also take multiple sources of data, so from multiple databases, and then produce that into a single target. So this is a very good example for analytics, where you've got multiple operational databases on-premise, and then you want to consolidate those in the cloud to a single target, such as Amazon Redshift. You don't actually have to take everything as well. So you can specify predicates and say that you only want to take partial data from some tables, or of course exclude some tables completely as well. So that gives you a lot of flexibility if you're, again, doing something like analytics, where you only want to take certain aspects of an operational system and subsets of data from particular tables to bring those across into a target system. And this is really a key capability. It's all about the choice of where you can move data around. So we have the capability to say, take Oracle data from an Oracle database and ship that to another Oracle database. And as you'll see, that can be different versions and editions of Oracle at each end. We can also take data from one database, such as Microsoft SQL Server, and change that to be hitting a MySQL database. And then another common one that we're seeing with custom Oracle to our database Amazon Aurora, which is our MySQL Enterprise version of the database that we've created inside Amazon. And that is now available in the Sydney region as well. So looking at the sources for the database migration service, there are a couple of things that you need to be aware of when looking at this. And you can see that it's all about version restrictions. Now this is to do mostly with the capability to support the CDC, or the change data capture feature. For example, Postgres 9.3 does not support us having the capability to use CDC, so we only support 9.4 and 9.5 at the moment, and obviously 9.6 when that comes out. Also, if you look down at the RDS capability, there are some restrictions on Microsoft SQL Server and Postgres. So if you have an RDS source, which is SQL Server or Postgres, then we don't support CDC on this particular database at the time. So if you've got a SQL Server database that's running on-prem or running an EC2, then that's fine. Same with Postgres. But explicitly in the RDS environment as a source, we don't support those operations yet. We will introduce those capabilities at a later date, and we are working on that, but as it stands at the moment, that's not something we can support. In terms of the targets, as you can see, the targets are slightly different, and again, the Postgres comes out where we can support 9.3 as a target. Not that I think you'll be going from 9.4 to 9.3, but it is available. And on the RDS side, you can see that we support all of the database versions that we have in RDS. And then there's a new database at the bottom, which is Amazon Redshift. So this is where we can take the more operational and relational data and put that into Amazon's data warehouse, Amazon Redshift. From a pricing perspective, and this is what gets a lot of people, typically, as we pointed out at the start of the presentation, there are tools out there such as Oracle Golden Gate, Informatica, and other tools that do support CDC. But the cost of those tools is quite prohibitive. So if we look at the comparison here, you can use something like a T2 Micro, this is US based pricing, but it's 1.8 cents per hour, and if you want to use multi-AZ, basically that doubles the price. So this is very cost effective to do testing on a T2 micro or a T2 small, and even for small jobs you may be able to use that for production migration tasks. And especially if you're looking for something where you want to do constant migration from on-prem into the cloud, but the transaction rate is quite small, then again the T2s, even the small instances, might be sufficient. Where you want to look at the C4s is where you have more CPU grunt from the C4s to process a larger number of transactions that are occurring on the source while you're doing the bulk transfer. And then, of course, those transactions need to be applied. Also, the database migration service does support some very small transformations. So it's definitely not an ETL tool. It's kind of more of an extract and load tool, but you can do some forms of transformations. So based on that, you may want to use a larger instance for that processing. You can see that we do provide some storage. So with the T2 instances, you get 50 gigabytes of SSD-backed storage, and for the C4 instances, 100 gigabytes. You can add more if you believe that you need more to store your transaction load while the bulk transfer is occurring, but that's what's given as part of the package. So from that, we believe that that's sufficient for most use cases, but again, if you find it's not during testing, you can definitely add more to cater for extra transactions. And remember that data transfer into Amazon Web Services is free, and if you're transferring across AZs, then it's 1 cent per gigabyte. So looking at what does this mean on an actual migration? Well, from the documentation, the development team actually did some tests, and they were able to migrate 5 terabytes of data in 33 hours. So this was in the best scenario. Everything was running on AWS from EC2 to an RDS database. So it's not dependent on the network connection that's coming from perhaps your on-premise site into AWS, which could be a major bottleneck. The database here that they were looking at included 4 large tables of 250 gigabytes, a huge 1 terabyte table, 1,000 of small to moderately sized tables, 3 tables which included lobs with different sizes of lobs inside that, and then 10,000 very small tables. So this is a fairly large and complex beast of a database that we were able to migrate in 33 hours in the best conditions, as I mentioned. The key point here is how much does it cost? And it would be for less than $10 per terabyte to do that particular migration. And this is, not at the low end. This is at the this is at the high end of what you could expect to pay. So it probably can be done much cheaper than this. And when you put that in the context of other tools, then I think you'll start to see just how cost effective it is to use the database migration service compared to the traditional providers. So the use cases, what can you actually do with DMS? Now obviously the number one is the title of this particular talk, which is the migration of business critical applications. And then the next one is migration from Classic to VPC. So if you've been using AWS for a while, our original network stack was actually called Classic, and then we introduced the virtual private cloud, which is a more secure networking concept. Now, there are still customers out there that do have applications and databases running in our Classic network, and to propagate that across to the VPC is essentially like a migration as well. So what we can do is to use DMS to do that Classic to VPC migration. If you're running Oracle and you would like to offload some reporting or perhaps read operations to help scale an application, traditionally you would need to use Oracle Enterprise Edition, and you would have to purchase the active data guard option for Oracle database. So you're having to use the top of the line Oracle database and pay for an additional option to get a read replica. What we can do with DMS is actually set up the replication from any edition of Oracle, whether that's Enterprise Edition, Standard Edition 1, or Standard Edition 2, and then set that as a target again for one of the cheaper versions of Oracle, or if you wish you could use Enterprise Edition, of course. But you don't need to pay for the active data guard option for this. And that can really save quite a lot of money when you're looking at doing things like analytics and offloading read operations. Read replicas on other engines as well. Same applies for SQL Server if you'd like a read replica for that. And then for MySQL, Postgres, if you want to do sub-selection of certain tables and you don't need the whole database, then you may prefer to use DMS over their native replication and read replica support that we have inside RDS. Looking at cross-region read replicas for Oracle and SQL Server, this is something that we do not support inside RDS at the moment, where we do support that for Postgres and MySQL and Aurora. So if you're looking at that, then what we can say is, instead of relying on RDS for that, now let's use DMS to take an RDS source and then propagate that across to another region to accelerate read operations in another region. Analytics in the cloud. As I mentioned, this was something that we can take consolidated systems from on-premise and push them into a single system in AWS to allow you to do analytics and to keep that data constantly updated with DMS performing that. And you can use the multi-AZ option with DMS to make sure that that propagation is always going to occur, even if there's an outage in a particular area of AWS. Another one which is interesting is dev test and production environment sync. Now, many of you, I'm sure, have been involved in projects where you've tested everything in dev test, but you never really had the production transaction load, and you never really had the production data set. It was always contrived data and contrived load tests. And once you put that into production, of course, it doesn't quite work as intended, and I'm sure many of you have heard about the Australian census problems over the last weekend. So if you were to have a production data environment that you could keep in sync with your dev test account, then you would actually be able to run your transaction load and use production data and keep that completely in sync by using DMS. So that's an interesting one to think about as one of the use cases for this new service. And what else could you do with DMS? You know, we've talked to a number of customers and they've come up with different ideas that they would, for their specific scenarios and use cases, use DMS for. And I'm sure that you have some other use cases that you would like to use DMS for as well. And if you do have something different, then tell us what are some of the things you'd like to do, or if there's something that it can't do at the moment, do tell us what you would like to do with it as well, and we can feed that back to the development team in Seattle. So what happens if your database is too big? This is a problem, especially if you're looking at things inside a country outside of the Sydney region. So if you're looking at, say, in New Zealand and moving data across to Sydney, then there are issues about trying to, say, move 5 terabytes or more data given the network bandwidth. So we do have a couple of different ways to help with that. One of them is to look at using AWS ImportExport disk to ship your hard disk to AWS. This is supported in the Singapore region. It's not available in the Sydney region at the moment. But we do have AWS ImportExport for Snowball, which is a secure storage appliance, which you can see on the right, with up to 80 terabytes that AWS ships to you, and then once you fill it up, it can be shipped back to AWS and loaded into S3 for you to then use that data. So if you do have something like a data warehouse and you would like to ship a lot of data there, then this is an ideal mechanism to do that. There's another way. If, let's say, you're sitting in Melbourne and your network connection up to Sydney is pretty much maximized and you don't have much capacity on it, then we do have a point of presence in Melbourne as part of our content delivery network, and you can use our S3 transfer acceleration capability. What this will do is basically give you the capability to upload data to that point in Melbourne, and from there we use the AWS backbone back to Sydney to then populate that data into the Sydney data centers. So that kind of gives you a more economical way to get data into AWS. Now, what about if you're going to look at doing a migration not just of the data from, say, Oracle to Oracle or SQL Server to SQL Server, but you're looking as part of a migration to AWS to actually change the underlying database. Well, that's where the AWS Schema Conversion tool comes in. So this tool is all about helping you take the schema, which is the database definitions in terms of the tables, the store procedures, the triggers, and other database-related objects, and moving them from one particular database engine to another. So what we support at the moment is the capability to convert relational databases, Oracle, SQL Server, MariaDB, Postgres, and MySQL, to the open source engines. So Postgres again, MariaDB, MySQL, and Amazon Aurora, which remember is a MySQL compatible database. So we're taking the commercial engines here and helping you move them to the open source engines, and also interchange between the open source engines. We are not giving you the capability to go from open source engines to the commercial engines. We're trying to save you money. Plus the providers, Oracle and Microsoft, do have their own conversion tools to help you with that. We've also recently introduced the capabilities to take Oracle schemas for Oracle data warehouses and Teradata and convert those to Amazon Redshift as well. So this also is a tool that's going to help you during the process. It's not a tool that is going to be a one-button magic push. So as you can see from the screen here, on the left-hand side, you've got the individual components from the source. On the right-hand side, you've got the target. And then in the middle, it's got information about what are some of the errors, and you can see there's an Oracle store procedure at the bottom and what that translates to into a MySQL store procedure. So there are going to be some automatic conversions done, but there are going to be a number of issues that you'll have to make decisions on, because there's going to be functions, procedures, internal database capabilities that are perhaps not there in the target. In terms of the objects, you can see what is supported on the right-hand side there, from sequences, user-defined types, synonyms, packages, etc. And all of those can be converted across to the target schema. Now, what is particularly useful about this tool is that it supports a report. And this report is a PDF document that you can run, and you don't actually have to do any migration whatsoever. It's basically pointing it at the source database, pointing it as the target is what you would like it to have. Let's say it's an Oracle database and you want to migrate it to MySQL or to Postgres. You choose the target, and then it will run through and analyze what are the particular things it can migrate automatically and what are some of the issues. And as you can see, there's a summary on the left-hand side there of what some of the findings. And side, you've got some of the things about things like sequence changes and index changes, constraint changes, and what those recommendations are and how many of them are. So this becomes a really useful tool to actually assess what the migration involves and how much effort would be involved in a particular database migration. Because quite often, if you're looking at an application, for example, that's meeting the business requirements, it's running, say, a Microsoft SQL Server today, you're concerned about the licensing costs of SQL Server and would like to save some money and move that to, say, MySQL. Well, if the actual migration cost of moving that, because of the complexity of the original database and the store procedures and the triggers that it has, is not really going to be worth it, because as I said, it's meeting the business requirements, then it may not make sense to actually do that migration just to save on license and support costs. However, on the contrary of that is that if you do have an application which is, say, 5 years old, it's no longer meeting the business requirements, it needs to be redeveloped and modernized, and as part of that strategy you're thinking about doing a migration to an open source database, then that can make business sense given the amount of effort that it takes to do a migration. Now, in my experience in many customer environments, there are plenty of Oracle databases and SQL Server databases that are sitting there just doing basic CRUD. They don't actually use a lot of stored procedures or triggers, and they could be converted very easily to Postgres or MySQL. So you have to actually understand what the environment is and what the database is like before doing these types of migrations. Now, the pricing. This is very important. It does not cost any money to use the Schema Conversion tool. It is a tool that you can download as long as you're in good standing with your AWS account, down to your laptop or your machine, server, or workstation, and run that. If you do want to use it to do migrations that are not going to be to the cloud, we do have the capability to offer some pricing for that, but as long as you're using it to migrate databases to Amazon RDS, Amazon Redshift, or the EC2-based databases, then it's free to use. And this is how it actually looks like from a database migration perspective. So the first step is that we're going to look at taking an Oracle database on-premise, in this case, which can be either in EC2 or RDS as well, then doing a schema conversion tool of that database to target Amazon Aurora. Now, the reason we need to do this first is that before the database migration service can take the data, we need to actually look at all of the tables and the data types and map those to Amazon Aurora. Because if we try to do the conversion, the tables will not be there if we use the database migration service, and some of the other things that you need, like store procedures and triggers, etc., won't be there for the application to run as well. So you definitely need to use the schema conversion tool first and make sure that the target schema is accurate and sufficient for that particular target database before you start bringing the database across. But once you've done that, then the next step is to point the database migration service to the source database and to the target database, just as we had explained previously. And once that's done, then it can start using the CDC capabilities to keep that application running on the source side as you're moving the data across to Aurora. And then hopefully you've got your new application, which has been changed to use SQL code that's suitable for Amazon Aurora versus Oracle. And once you've got all of the data across, then you're going to point your users at that new application environment running in AWS, and the downtime will be very, very minimal when you make that switch over. So looking at some customers who've actually used the database migration tool, Expedia, which you've probably heard of, is a world-leading online travel company, and they have used it to take some databases to Amazon Aurora. And you can see here from the quote, the ease by which we can do this using AWS Database Migration Service has simplified this process for us and enabled us to accelerate our migration efforts. And a key point they're mentioning here is the ability to monitor the process and see how it's going, as well as the logging feature, so they can see what actually happened during the process if there were any problems, especially during testing, to make sure that the whole thing is going to go smoothly when you do it from a production perspective. Another one, Tomasz Publishing. They connect buyers and suppliers across all different industrial sectors, and they're going from a traditional, print publisher to a digital-friendly business. And as part of that, they're going to have to increase their Oracle database footprint. And because of that, that would increase the licensing and ongoing support costs associated with that. So they wanted to try and migrate to Amazon Aurora to save cost. And they found that the database migration service automated most of the work, and they also found that that is going to be something that they will continue to use as they move more of their footprint from Oracle into Amazon Aurora in 2016. Another one, Pegasus Systems, they are looking at doing a different track where they're taking an Oracle database to Postgres using our relational database service. And once they've done that, they experience better availability and performance in the AWS environment. And they were using things such as the Elastic Load Balancer, auto scaling in the middle tier, and of course the RDS multi-AZ feature which allows them to remove any single points of failure in the architecture. So, of course, they experience cost savings by moving from Oracle to RDS Postgres as well. So that's 3 customers to give you an idea of what their capabilities they've been able to use on DMS to help them move from Oracle database to Aurora, or in this case, Oracle to Postgres. Now, as part of the whole migration process, there are concerns with some customers about whether they have the capabilities inside their companies to be able to do the migrations. So we are working on developing a number of different database migration partners, and these are some of the international companies that we have at the moment. I'm also working across APAC to develop some of the local partners, and I'll be meeting with some partners in Australia next week to get some capabilities around the database migration service and to help customers do assessments, the actual migrations, and even look at some of the application migrations as well in terms of the code changes that are needed there. But if you've also got capabilities in your own company where you feel comfortable using a tool like this and you've got expertise, especially if you're doing a migration from Oracle or SQL Server to an open source engine, you've got expertise on both sides of that, then yes, you can definitely go ahead and do it yourself. But if you prefer to get a partner in, then you can contact one of these partners to help you with the migration. So if we look at the issues that we raised at the top of the hour and what we have talked about as we've gone through the presentation, the biggest one that we mentioned for business critical applications is that our customers can't afford any application downtime for those types of applications. So we talked about how we actually have got the database migration service that supports change data capture, or CDC, to minimize the amount of downtime by allowing the application to stay up and the transactions to be propagated as the migration is happening from the source to the target system. So once that propagation is up to date, then it's minimal downtime to actually switch the application users from that source system to the target. So that's something that we have now addressed. The next one is the tools that enable minimal downtime are expensive. Now remember that we were talking about moving a terabyte of data for less than $10, and that's a huge reduction compared with the likes of Oracle Golden Gate, where you have to license the source processes and the target processes. And even if you were to run ongoing replication constantly, you would still be saving a huge amount of money based on the cost of DMS, and combining that with the Schema Conversion tool if you want to do a migration from a commercial engine to an open source, which is also free, then you have a much lower cost tool experience for this. And from the complexity angle as well, as you can see, the complexity of the console is very simple, where the way you actually go through, if you go and look at the tool to do setting up a source and then setting up a target, is very, very simple as well. It's all about just defining the database connections and then selecting what you want to migrate from that. So the complexity of the tools are much, much simpler as well. From the ability to need to have a copy of the data on-premise, whether you want to keep that master copy on-premise and propagate that data into the cloud, or whether you want to have production in the cloud but keep a copy of that on-premise, then DMS supports that and gives you that capability to either perhaps even have DR scenarios where you have production in the cloud or production on-premise, and being able to swap back and forth before that if you want to use your existing infrastructure from a DR perspective. So that's also being dealt with. And then I mentioned about the Schema Conversion tool if you want to migrate to an open source database, and not only from commercial engines, but as I said, between MySQL and Postgres as well. Then looking at sending the large volumes of data to AWS traditionally requires an expensive international network link, or even in-country. It can be helped with different things like the S3 acceleration that we have, and then Snowball for you for bringing large amounts of data into AWS. So that's also been addressed. And then if you don't have the skills inside your organization, we do have partners who are able to help you with the migrations. So what that means now is once we've addressed these common concerns is that now you can migrate your business critical applications to AWS. Obviously there's still work involved, but the risk, the cost, and the complexity have been dramatically reduced to enable you to do these migrations by the introduction of the database migration service specifically, and of course for the Schema Conversion tool to help you with heterogeneous migrations. So I'd just like to cover off a couple of things before we end up on this. The AWS team in ANZ has actually revived the podcast, and this at the moment is occurring on a monthly basis. So this is something where we're going to talk about the latest releases of features and services and what's happening with AWS. So if you want to get involved in that, this is where you can sign up for it. And I think we're going to be able to take some questions, and I'll see if there's any questions that I need to have a look at and answer. And also, if you do have more complex questions that you would like to write something that's quite long and you need to get that answered, you can send an email to the AWS-ANZ-marketing@amazon.com address, and we will make sure that somebody is going to be able to attend to that and get you an answer. So I'd like to ask the guys if there's any questions for me, could they send them to me? And while I'm waiting to see if there's any questions, I will address some common ones that I tend to get asked as well. So with the migration of objects using DMS, are there restrictions of certain things that we can't move? And one of the particular ones that comes up again and again is large objects or LOBs, binary objects and text objects as well. There are some restrictions that you might find if you launch the tool and the service by default, and there are tuning optimizations that you can do to make sure that you have the right size buffers for large objects. So you can, for each of the different databases, read the documentation and see what some of the restrictions are for the types of objects that we can move, and you will have to make some adjustments for your particular database source. So there's one database question that's come through. Can data be obfuscated when replicating to dev test with the built-in transformation capabilities? No, at the moment we do not support any data masking or obfuscation using the service. That is definitely something that we've heard from customers, and we are actually working with partners. So two partners that I have talked to and are actively talking to. One is Data Guys, and another one is Delphix. Both of those companies do have data masking capabilities, and we're talking to them to see how we can recommend those partners for particular solutions with customers. And this is very relevant for customers who have oversight, such as financial companies or telcos, and they need to make sure that data is obfuscated when it's going to even their own dev test accounts, even if it's on premise, as well as when they're moving data from the cloud in production, even on-prem, and from on-prem into the cloud, just to make sure that data is obfuscated before it gets into the cloud environment. So there's no, unfortunately, straightforward answer to say, yep, we recommend this particular solution at this point in time, but the traditional players are also there. So Oracle does have data masking capabilities, IBM too, and then also Informatica does support capabilities. So the traditional players are there, and then there's other niche partners, as I mentioned, such as Data Guys and Delphix, who are able to help with some of these aspects. Another one that's come through is, what is the load on the source and target databases. So what we're actually doing is we're using mining the logs and taking the transactions from that and applying those again. So this is for CDC. The initial load, where we're doing the bulk load and select star on a table, that will have an impact on production systems. So you want to do that bulk load at an off-peak time, because we will be doing select stars on the tables. As I mentioned, you can actually refine that by specifying the parallelism of the number of tables that you're going to do at a time. So if you want to do it an ongoing migration, and it's going to take, say, 2 days to migrate the data because of the volume of transactions and the volume of data in your network, then what you might want to do is bring the parallelism down to make sure the load on the server is not that high. Now, for the ongoing replication, then the load is quite low, because we're actually mining the logs and then applying those changes onto the target system as they're happening on the source. So yes, there'll be some overhead and network traffic and I/O and those types of things, but it's not going to be as much as when we're doing the bulk transfer at the start. Next one that's come through is, let me have a look, of using the service to keep a read replica in sync and perform a database upgrade on the source schema. How do we keep the read replica and sync the service updated? Yeah, if you were going to do something like a database upgrade, I can take that to be a couple of things. So let's say you're going to make massive schema changes where you're going to add a number of tables and different columns. We actually allow you to then create another task where you could define the migration of those tables and columns. On existing tables, we do support in most of the databases picking up another column. The things that we won't support are changes to store procedures and triggers. Those do not get propagated across with DMS. It literally is about moving the data, not about moving the database objects that involve code, such as triggers, store procedures, and so on. That's where the Schema Conversion tool comes into play for those things. So if you're looking for something to put a read replica in place, which is for an actively developed system, then you would have to put mechanisms in place to make sure that if you're making changes on a store procedure in production, that you would also have to make those changes to the read replica. So if you do have those types of requirements, that's where you might be better off using the native replication technology of, say, Oracle, SQL Server, MySQL, Postgres, etc., to do these types of read replicas. Of course, you will, on the commercial engines, have to pay more for that, but given the capabilities of DMS at this time, that is a restriction. Any more questions? When looking at a migration of EC2 Microsoft SQL Server to RDS Aurora database, what are the issues and limitations? Okay, so let's look at the big picture here of where you're going to go for different database types. If you think about the maturity of different database engines, Oracle has the most features. It still is the most scalable and highest performance database out there. SQL Server is behind that in terms of features, capabilities, and scalabilities, but it's still very good. We typically see that Postgres performs very, very well, and each revision from 9.4 to 9.5, and indeed what's happening with 9.6, is becoming extremely scalable and very high performance. However, it doesn't have as many features and capabilities as the commercial engines. Dropping down another level, you're looking at MariaDB, MySQL, and of course Aurora, which is all of the MySQL family. The features and functions of that family is again less than Postgres and far less than the commercial vendors. Whilst we have better performance with MariaDB compared to MySQL, as well as with Aurora having superior performance, availability, and scalability above MySQL, the core features are roughly the same on the MySQL platform. So if you're taking a database that is from the commercial engines, which of course can have many, many features used, and over years we have a lot of store procedures, a lot of triggers, and then you're going to try and say, let's put that into something like MySQL. Well, unfortunately, that's going to be a pretty big ask. What we typically see is from the commercial engines that customers would, for simple use cases, favor MySQL because there's familiarity around that. For more complex use cases, Postgres is a better target, especially because of the features around things like spatial JSON support, and in 9.6 they're going to be introducing parallel queries, so for larger queries and analytics, Postgres is going to get a big boost as well. So we tend to see, especially for Oracle, that Postgres is a great target, and this is because the architecture of Postgres and the language of Postgres is also much closer to Oracle. So you have to kind of look at the different databases and what the targets are, what the complexities are, and of course what your skill sets are, to be able to decide what's the right target. So there's no easy answer, but hopefully that's given you some idea of what are the concerns that you have to look at when deciding to move from a commercial engine like SQL Server or Oracle to the open source engines. Another question on roadmap, do we have a DB2 migration in the pipeline, that is support from for DMS or for the Schema Conversion tool? At this stage, we don't. We actually released one which I haven't put in, a Sybase capability for DMS, so you can actually move data from Sybase to any of the targets as well. But at this time, we do not have a DB2 coming up. And another question coming through is, what about the ongoing copying of sequence values that need to align with values within the tables? Well, if you're applying a transaction on the master database that's going to use a sequence value, then that value that's been assigned is going to then be propagated across to the other database. Now, if you're talking about whether the sequences themselves are going to be kept up to date, I would suspect, and this is just a guess at this time, that that would not be the case, because unless you're relying on that sequence being used at the other end, then that sequence is not going to be updated with the latest values. I can't say that accurately because I haven't tested it, but at the just asking off the cuff, that's my response to that. Probably is not the case. If you would like to collect that particular question, we can get back with an official answer after the webinar. Okay, so I understand that that was the last question at the moment. So thank you very much, everyone, for attending today's webinar. Again, if you have further questions, please feel free to send an email to the email address on the screen. I hope you have learnt a lot today about how you can now migrate your business critical applications to AWS, and thank you very much for your time.